Good day, viewers all over the world. Welcome to Today online class. Today, we want to continue our topic on polynomials. So, when I introduce polynomials, we have given the definition of polynomials. We have discussed about addition and subtraction of polynomials. We have discussed multiplication of polynomials, division of polynomials. Then I've introduced Remainder Theorem briefly. So I want to continue from Remainder Theorem. But before I do that, I will briefly go over reminders, the division of polynomials. For instance, if you have a polynomial p of x, which is equal to x cubed plus 3x squared minus x plus 1 divided by polynomial q of s, which is given as x minus 2. Of course, if you want to do this, we use the long division method. This will be x cubed plus 3x squared minus x plus 1 divided by x minus 2. Okay, if you want to divide this, we are going to look at the coefficient, the power, the index of this x cube. Here is x. What are we going to use to multiply x to give us x cube? That is x squared. We now say x squared times x, that is x cube, minus 2 times x squared, that will be minus 2x squared. So naturally, we introduce minus. So minus here will be minus, the minus times minus, this changes to plus. This will cancel out. Then at the end of the day, I will have 5x squared minus x. So we also look at what we can use to multiply x that will give us 5x squared. That will be 5x. 5x times x, that will be 5x squared minus 10x. Of course, we introduced the natural negative. So this will be minus times minus will be plus. This will cancel out. And at the end of the day, we are going to have 9x, then plus 1. We bring out this. Then at this stage, we are going to say this is plus 9. Because when we use 9 to multiply x, we are going to get 9x. So 9 times x, that is 9x, minus 2 times 9, 18. So when we introduce negative, this will be minus, this will change to plus. This will cancel this. At the end of the day, we are going to get 19. So in the last class, I said the implication of this is that this polynomial or dividend or what we are given, x cubed plus 3x squared minus x plus 1 is same thing as you using this divisor, x minus 2, to multiply the result or quotient x squared plus 5x plus 9 plus the remainder, which is 19. That is just like when you have at the elementary, when you have 9 divided by 2. 2 in 9, is 4. 4 times 2, 8. There will be natural negative, you have 1. Then how do I get this my 9? 9 will now be equal to 2 times 4. 2 times 4 plus 1. So in this case also, when you have this polynomial being divided by this divisor, this polynomial now, if you want to get the value of this polynomial, it will be divisor multiplied by a result or quotient plus remainder. Then here, what I have here is called the polynomial. This is called the polynomial, or you can call it dividend. This one is called divisor. This is what we use to divide. Then this result is called the quotient. This is called quotient or result. Then 19 is given as remainder. This is the remainder. So by formula, we have established this in the first class on polynomial. I just want to do a recap. We are given that polynomial is equal to divisor multiplied by quotient plus remainder, and that is the formula. So if you are given the divisor, you are given the remainder, you are given the result, you can find the polynomial. But instead of dividing using this long division method, how can I get a remainder once I'm given the polynomial and the quotient? That is what is going to lead us to what is called the remainder theorem. And the remainder theorem, that will lead us to remainder theorem. So under the remainder theorem, it says that the remainder theorem states that if the polynomial, let's say f of x, is divided by x minus a. The remainder is f of a. What is the implication of this? Like the polynomial that we are given the other time, p of x, which is given as s cubed plus 3s squared minus x plus 1. And we have divisor x minus 2. We have this as x minus 2, which is q of x. This is divided by this. So instead of using the long division method before we can know the remainder, this theorem is telling us that if you have a polynomial f of x, let's say this is f of x now, f of x, and if it's divided by the quotient that we have q of x, as we are given s minus 2, which is s minus 2, then the theorem is telling us that the remainder will now be just like when we have x minus a, say equal to 0, then x equal to a. So for us to get the remainder now, let's just substitute the value of x equal to a. Once we substitute, just like in this case now, it's x minus 2. When I make a subject of formula, if I equate this to 0, I'm going to get x equal to 2. If I substitute f of 2, whatever I come across, I realize it is called the remainder to this polynomial. And that is what the theorem says. So if I apply the theorem now, instead of using my long division method, I can get my remainder. So the divisor is s minus 2. Then what is s? Just assume that s minus 2 equal to 0. So x will be equal to 2. So substitute for f of 2, that is when x equal to 2. Once I substitute the value here, the result is going to give me the remainder. In this case now, I will have 2 raised to the power 3 plus 3 multiplied by 2 squared minus 2 plus 1. This is going to give me 8. 2 times 2, 4, 4 times 3, 12. This is 12 minus 2 plus 1. This is 21 minus 2. And that's going to give me 19. So f of 2 is equal to 19. You realize that when we use the long division method, at the end of the day, the remainder is 19. So in this case now, my f of I can get the remainder of a polynomial without using the long division method. Once I know the divisor, just make s the subject of formula in the divisor, substitute inside the polynomial. The result is called the remainder. So that's remainder theorem. And there's this other theorem called the factor theorem. There's another theorem that we are going to state. It's called the factor theorem. The factor theorem simply means that when we substitute for f of a in the remainder theorem, if our remainder is 0, then it shows that this divisor is the factor of the polynomial. So that's what the theorem states. Factor theorem is just the extension of remainder theorem. Factor theorem states that if f of a, that is what guarantees the remainder, equal to 0, then the divisor x minus a is a factor of f of x. That is, if you are given a polynomial and a divisor, when you substitute the value of that of that divisor into the polynomial, and if your result is 0, it simply means that this x minus a is a factor of f of x. So I'm going to give an example on that. I'll give one example on that. So example, find the remainder when f of x, which is equal to 2x cubed plus 3x squared minus 4x plus 1 is divided. When it is divided by 2x minus 1. So what conclusion can you draw? That is, in this case now, what are we given? We are given f of x, which is the polynomial, as 2x cubed plus 3x squared minus 4x plus 1. Then how do I get the remainder? I can get the remainder without the long division method. I'll just say 2x minus 1 equal to 0. I'll make s the subject formula. So 2x is equal to 1. S is equal to half. That is, for me to get the remainder of this polynomial, I'll just say f of half. And that will give me, wherever you see x here, you change it to half. So in this case now, I'm going to have 2 into bracket 1 all over 2 cube plus 3 into bracket 1 all over 2 squared minus 4 into bracket half plus 1. Then this is going to give me 2. 2 times 2 times 2, 2 in 3 places, that is 8, plus this is 3 all over 4 minus here 1, here 2, minus 2 plus 1 over 1 over 1. So if you find the LCM, it is 8. This will give me 2 plus 4, that is 6, minus 16 plus 8. Then if you do that correctly, 2 plus 6 is 8. 8 plus 8 is 16. 16 minus 16, that will be 0 all over 8. That gives 0. So in this case now, if you look at this question, in this case, f of half is equal to 0. In this case, the remainder is equal to 0. And from the factor theorem, if the remainder is equal to 0, it simply means that the divisor, that is in this case 2x minus 1, is a factor of this polynomial. So the remainder in this case now, the remainder is 0. So what can we conclude? What can we draw from this? Hence, we just say 2x minus 1 is a factor of f of x. And that is the conclusion. 2x minus 1 is a factor of f of x. That's the conclusion. So we take another example. So we have seen the implication of factor theorem now. Whenever you substitute the value of your divisor, make x the subject formula there, you substitute into the polynomial. If the remainder is 0, it simply means that your divisor is a factor of that polynomial. And that is all about factor theorem. So let's give another example, say example 2, to see the implication of the question. So this question says that when the polynomial h of x, which is given as ds cubed plus fs squared minus 7x plus 6, no, minus 6. So when this polynomial is divided by x minus 1, the remainder is minus 10. And when it is divided by x minus 3, the remainder is 36. So the question now says find the values of the constants d and f. Of course, in this case now, what is the polynomial? H of x, which is equal to ds cubed plus fs squared minus 7x minus 6. That is the polynomial. So the question says that when this polynomial is divided by x minus 1, in this case now you have x minus 1, which is equal to 0, then x is equal to 1. So you substitute for h of 1 when x is equal to 1. That will be d into bracket 1 cube plus f into bracket 1 squared minus 7 into bracket 1 minus 6. The remainder is given as what? Minus 10. That's the question. Then if you solve this, we are going to have d here plus f minus 7 minus 6 is equal to minus 10. So we are going to have d plus f minus 13 equal to minus 10. So d plus f now will now be equal to minus 10 plus 13. So d plus f is equal to 3, equation 1. That is what we get. Then the question, we continue the question. So when this same polynomial is divided by x minus 3, so in this case now, when the factor is x minus 3, that simply means that when x is equal to 3, that's what we are going to have. X minus 3 is when x is equal to 3. And it being what you have here is x plus 3, that will be when x is equal to minus 1. Then x of 3, then we go to this polynomial again and substitute d into bracket 3 cube plus f into bracket 3 squared minus 7 into bracket 3 minus 6. So when it is divided by x minus 3, the remainder is 36. Just equate it to 36. The remainder is 36. Equate it to 36. Then what do we get here? We are going to have 27d plus 9f minus 21 minus 6 equal to 36. So here we are going to have 27d plus 9f minus 27 equal to 36. So we have 27d plus 9f to be equal to 36 plus 27. Then from there, we have 27d plus 9f to be equal to 63. So divide both sides divide through by 9. And if you do that, we are going to have 3d plus f is equal to 7, equation 2. So that will be equation 2. So we have 2 equations now with 2 variables. So when we have two equations with 2 variables, we are going to solve it simultaneously. So this is 3f is equal to 7d, equation 2. Then the equation 1 is d plus f is equal to 3, equation 1. So we have two equations with two variables, so we solve this simultaneously. Then we can say equation 2 minus equation 1. 3d minus d, that's 2d. F minus f, this will cancel out. Then we have this is equal to 4. Divide both side by 2. So d is equal to 2. So we have gotten the value of d. So once we know the value of d, then we can substitute. Just say substitute d is equal to 2 into equation 1. What is equation 1? D plus f equal 3. Then 2 plus f is equal to 3. F is equal to 3 minus 2. So f is equal to 1. Therefore, we have been able to show that d is equal to 2 and f is equal to 1. And that's what we are asked to do. So that's what we are asked to do. So we have seen the implication of remainder theorem and factors theorem. So I'm going to introduce zeros of polynomial, which is the last concept, zeros of polynomial, that we are going to talk about under polynomials. So zeros of polynomial. What do I mean by that? You know, when you have an equation, say x cubed, x squared plus 3s plus 5 equal to 0. What we normally do is that we are going to solve this to get 0. But if you have, say, f of x is equal to x squared plus 3x plus 5, you know, this is the function. So you can't be talking about the root of the equation. The only thing we can do to this function is to equate it to 0. So if you equate this to 0, then when we solve the function, we can't call this root of the equation, we call it the zeros of this function. So under the zeros of polynomial, it simply means that whatever polynomial we are given, we equate it to 0 in order to get the zeros of that polynomial. For instance, let's say example 3. Example 3, we say find the zeros of the polynomial. Find the zeros of the polynomials. So what is the polynomial? P of x is equal to x squared minus 5x plus 6. So how do we get the zeros of this polynomial? The only thing that we can do is that we put P of x to be equal to 0, so that x squared minus 5x plus 6 will be equal to 0. So we can go ahead and factorize this. We are going to have x squared minus 3x minus 2x plus 6 equal to 0. Now this is a quadratic expression, so we can factorize this. So x is common, we have x minus 3. Minus 2 is common, we have x minus 3 equal to 0. So here we have x minus 2 equals 0, or x minus 3 equals 0. So here we have x is equal to 2, or x is equal to 3. Therefore, x is equal to 2 or 3. So in this case now, the zeros of p of x now, the zeros of p of x will be, the zeros of p of x will now be 2. The zeros of p of x is, or are, 2 and 3. That's what we get. The zeros of p of x, no, here is plus, this is plus, this is plus. So here will be plus, plus, this is plus, 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 plus. So here I'm going to have minus, it will be minus, it will be minus 2 or minus 3. So the zeros of p of x are minus 2 and minus 3. That is what we are expected to get. Okay, we also give another example. Let's give another example before we call it a day. And in this example, say example 4. Example 4. We have that the remainder when the polynomial, let me abbreviate polynomial, when the polynomial, the remainder when the polynomial f of x is equal to ax cubed plus 3x squared plus bx plus 5 plus 15, when the polynomial is divided by x minus 1 is minus 12. So when it is divided by x minus 2, the remainder is minus 21. So find now the question, Roman figure 1, the values of the constants, the values of the constants a and b. Then Roman figure 2, the zeros of f of x, that is the zeros of the polynomial. That's the question. So solution, what is the polynomial? F of x is equal to ax cubed plus 3x squared plus bx plus 15. So when this polynomial is divided by x minus 1, of course, when you have x minus 1, that will be equal to 0. So x equal to 1. That is, we talk about f of 1. F of 1 now, you substitute when x equal to 1, a 1 cube plus 3 1 squared plus b into bracket 1 plus 15. When we substitute for x of 1, the remainder is minus 12. Just say minus 12. Then here we are going to have a plus 3 plus b plus 15 is equal to minus 12. So here we are going to have a plus b to be equal to minus 12 minus 18. So a plus b is equal to minus 30, equation 1. That's what you have. Then the second one says that when this polynomial f of x is divided by x minus 2, that is when x equal to 2, then f of 2 will now be, we substitute for the value, a into bracket 2 raised to power 3 plus 3 into bracket 2 squared plus b multiplied by 2 plus 15. When it's divided by x minus 2, the remainder is minus 21. So let's simplify that. It's minus 21. So we have 8a plus 12 plus 2b plus 15 to be equal to minus 21. We have 8a plus 2b. This is equal to minus 21. 12 plus 15 is 27. We have minus 27. So we have 8a plus 2b to be equal to minus 48. We can divide through by 2. At the end of the day, we have 4a plus b to be equal to minus 24, equation 2. So there are two equations here with two variables, so we solve it simultaneously. So this is equation 2. Then we bring equation 1, a plus b equal to minus 30, equation 1. So let's say equation 2 minus equation 1. Equation 2 minus equation 1, we have 3a. This will cancel out. Then minus 24 minus, that's 6. Divide both side by 3. So a is equal to 2. We have gotten the value of a to be equal to 2. What do we now do? We substitute. So substitute a is equal to 2 into equation 1. So what is equation 1? A plus b is equal to 30. So a is 2. 2 plus b is equal to 30. So b is equal to 30 minus 2. So b is equal to 30 minus 2. Then b is equal to 28. Therefore, the Roman figure 1, that Roman figure 1 that we are the first question, a is equal to 2 and b is equal to 28. So we have been able to solve that. Then we can go ahead and write the complete value now. So we can go ahead and write the complete value now. So that function now, f of x, the function f of x automatically will now be, instead of a now, we know that a is 2, we have 2x cubed plus 3x squared, then plus b is 28, we have 28x plus 15. This is the polynomial. So the second question says we should find the zeros of this polynomial. So how do we find the zeros of this polynomial? We equate everything to be equal to 0. But in this case now, none of the two factors that we have is a factor of this polynomial. So what do we do? If you are given a polynomial without factor, then we can actually, we now look for the factor. That is, you get that by guessing. That is, you look for the value of x that will make this polynomial 0. So in this case now, what if you say x minus 3 equal to 0, so that x equal to 3. So if you substitute for f of 3, are we going to get 0 here? That is 2. Are we going to get 0? In the question, I think we have, in the question, do we have minus there? Yes. In that question, one place is minus there. It is minus 28. That is minus 28. That's what you get. No, let me go over it again. If a, we got a to be equal to 2. So if you substitute a equal to 2 into equation 1, what is equation 1? A plus b is equal to minus 30. So we are going to get, okay, so this is f of x will now be equal to 2x cubed plus 3x squared minus 32x plus 15. So no, what we have is plus 28. Okay, so how do we now get the zeros of this polynomial? We think about the value of x that will make this polynomial 0. If we look at minus 3, are we going to get this? If this is minus 3, that's 84. This is 3 times 3, 9, 9 times 3, 27. I'm going to have 27 here. But it seems there is error in the question. Normally, the value of b ought to be minus from what we got. If you look at that two equations, there's a mistake there. If you look at the two equations, we got a to be 2. Then when we substitute, when a equal to 2, if we substitute, let's substitute a is equal to 2 into equation 1. What is equation 1? Equation 1 is a plus b is equal to minus 30. So 2 plus b is equal to minus 30. It's minus 30 that we have there. So that b is equal to minus 30 minus 2. Then b is equal to minus 32. So b is equal to minus 32. So a is equal to 2 and b is equal to minus 32. That is what we are supposed to have. So if that is the case, then the f of x, when we substitute back in the f of x, so I'm going to get, instead of f of x is a x cubed plus 3 x squared plus bx plus 15 will now be 2x cubed plus 3x squared minus 32b minus 32x plus 15. So this is f of x. This is f of x that we ought to have. Then how do we now find the zeros of this f of x? That will be equal to 0. In this case now, let's try f of 3. When x equal to 3, are we going to get 0? This is 2 into bracket 3 cube plus 3 into bracket 3 raised to power 2 minus 32 into bracket 3 plus 15. Are we going to get 0? That's what we want to check. So 3 times 3, 9, 9 times 3, 27. This will be 54 plus 3 times 2, 3 times 3, 9, 9 times 3, this is 27 plus 15 minus 96. This plus this is 81. So we have 96 minus 96. So that will be equal to 0. Then that simply means that x minus 3 is a factor. Is a factor of f of x. That's what we get. So please check this. I want you to go over it and check the solution. So if this is a factor, then I know what to do. Since this is a factor, I'll just use x minus 3 to divide the polynomial and get the other factors. I'll just use x minus 3 to divide the polynomial. X minus 3, I will use it to divide the polynomial to get other factors. 2x cubed plus 3x squared minus 32x plus 15. So what will I use to multiply x to get 2x squared? 2x cubed, that's 2x squared. This time this is 2x cubed minus 6x squared. If I introduce minus, this will cancel out, this will be plus. Then I'm going to have 9x squared minus 32x. So what will I use to multiply x to get 9x squared? That's plus 9x. Then I'm going to have 9x squared minus 27x. When I introduce minus, this changes to plus. This will cancel out. I'm going to have minus 5x plus 15. So I will introduce minus 5 here, so that I'm going to get minus 5x plus 15. When I introduce negative, this will be plus, this will be minus. Then the remainder is 0. So it shows that my f of x, which is equal to 2x cubed plus 3x squared minus 32x plus 15, is same thing as the divisor x minus 3 multiplied by the quotient 2x squared plus 9x minus 5. So how do I find the zeros of this? To get the zeros of this, I'll just say f of x, I will put f of x to be equal to 0. So in this case now, instead of this my polynomial, it has been broken down to this. I'll just say x minus 3 into bracket 2x squared plus 9x minus 5 equal to 0. Then I will have x minus 3 into bracket. I can factorize this to be 2x squared minus 10 plus 10x minus 5 equal to 0. So I can do the grouping. So here I will have x minus 3 to be equal to 2 into bracket s plus 5, then minus 1 into bracket x plus 5 equals 0. So from there now, I'm going to have x minus 3, which is a factor. I'll combine these two. What is common here is 1. So 2x is common here, 2x. So I will now combine these two. I will say 2x minus 1, then x plus 5 equal to 0. Here, x minus 3 equals 0, or 2x minus 1 equals 0, or x plus 5 equals 0. So that x is equal to 3, or x is equal to half, or x is equal to minus 5. So the zeros of f of x are, we have 3, minus 5, and half. So that is how to find the zeros of a polynomial. So if you want to find the zeros of a polynomial, just put that polynomial equal to 0. So that the polynomial, the function can become an equation, then you solve it. So I would love to stop the class here. So if you have further questions under polynomial, that is remainder theorem, factor theorem, and zeros of a polynomial, you can just put it in the comment section. I promise to attend to it. Thank you.